In the previous chapters, we studied the descriptive statistics, which is concerned with the summarizing data collected from the past event. And now we turn to the second part of the statistics. We call it inferential statistics. Means we're going to compute the chance of something will occur in the future. We call that probability. So in general, probability is a number that describes the chance that something will happen. So if the value of the probability is 0, means something cannot happen. If the probability is 1, means something surely will happen. So probability is a value between 0 and 1 inclusive, describing the relative possibility event will occur. Before we learn the probability, we first need to know some concept. First, experiment. Experiment is a process that leads to occurrence of one or only one of the several possible observations. Outcome. Outcome is a particular result of an experiment. Event. Event is a collection of one or more outcomes of an experiment. For example, I try to roll a die. That is experiment. From this experiment, there will be some possible outcomes. For example, one spot face up. After I roll a die, one spot face up. That is one outcome. Or I roll a die and 2 spots face up. That's also an outcome of the experiment. Or the outcome being the 6 spots face up. That's also the outcome, one of the outcomes of the experiment. And the event, there are several possible events. For example, events of the even number of the spots face up. For example, 2 spots face up, 4 spots face up, 6 spots face up. Those are all the even number spots face up. That belong to one event. Or the event of observing a number greater than 4. So the outcome of spots 5 face up or 6 spots face up all belong to this event, the number greater than 4. Okay, next. The next few concepts we have to know. Mutually exclusive events and collectively exhaustive events. Events are mutually exclusive if the occurrence of any one event means that none of others can occur at the same time. For example, I roll a die or toss a die, and one spot face up and 2 spots face up cannot happen at the same time. I roll a die, the outcome will be 1 spot face up, or 2 spots face up, or 3 spots face up. Cannot be 2 spots face up and 3 spots face up at the same time. So those events out of the experiment of rolling a die are mutually exclusive. Events are independent if the occurrence of one event does not affect the occurrence of another. Again, using the same example. So I roll a die, the result is 1 spot up. Will not affect the result of my second event, the second try. I roll another die and the result will be 1 spot up again or 2 spots up again. That result will not be affected by the first try, first experiment. So those experiments and the result events are independent because one event does not affect the occurrence of another. Events are collectively exhaustive if at least one of the events must occur when an experiment is conducted. So let's check the last slide. Here, that's all possible outcomes. So if I roll a die, all possible outcomes are listed here. Observe of 1 spot up, observe 2 spots up, observe 3 spots up, 4 spots up, 5 spots up, 6 spots up. All possible outcomes are all listed here. So we say the events like this are collectively exhaustive. There are several ways assigning the probability. Means there are several ways to calculate the probability, but here in this class we only learn the classical probability. So remember, first, the classical probability is based on the assumption that outcomes of an experiment are equally likely. How to understand this? Again, use the same example. Roll a die. So the outcome of an experiment are equally likely means I roll a die, one spot face up has an equal chance as the 2 spots face up or 3 spots face up. All these are outcomes of the rolling a die have the equal chance. So for this kind of the event, the probability of an event equal to number of the favorable outcomes over total number of possible outcomes. Check this example. Consider an experiment of rolling a 6-sided die. What is the probability of an event? An even number of spots appear face up. The possible outcomes are 1 spot face up, 2 spot, 3 spot, 4 spot, 5 spot, 6 spot. There are 3 favorable outcomes, 2, 4, and 6. They are even number of spots. There are 3 favorable outcomes in the collection of 6 equally likely possible outcomes. So the result is 3 over 6. So the probability of even number of spots will be a half, 50%. Okay, rules for computing probabilities. First, rules of addition. There are 2 kinds of rules of addition. First, special rule of addition. Second, general rule of addition. Special rule of addition. If 2 events A and B are mutually exclusive. So remember, mutually exclusive means A and B cannot happen at the same time. The probability of one or the other events occurring equals the sum of their probabilities. So means the probability of A or B happens equal to the probability of A plus probability of B. General rule of addition. If A and B are 2 events that are not mutually exclusive, then probability A happens or B happens is given by the following formula. A or B equal to probability A plus probability of B happens minus the probability of A and B both happen. Example. This example for the special rule of addition. When the 2 events are mutually exclusive, means when the 2 events will not happen at the same time. and we want to know the probability they happen. An automatic shaw machine fills plastic bag with a mixture beans, broccoli, and other vegetables. Most of the bags contain the correct weight, but because of the variation in the size of the beans and other vegetables, a package might be underweight or overweight. A check of 4,000 packages filled in the past month revealed. Event A, underweight. The number of packages is 100. Probability of occurrence is 0.025. Satisfactory. Event B, number of the package 3600. Probability of occurrence is 0.9. And event C, overweight. Number of packages 300. Probability of occurrence 0.075. So how do we find out the probability for each event? Remember, we use a classical approach of the probability. For the probability A, we use the favorable number of the probability A over the total numbers. So probability A equal to 100 over 4,000. We got the 0.025. And the probability for the event B, the same. For event B, the favorable number is 3600. We use this number divided by the total number 4,000. We got the 0.9. And the probability for the C is the 300 divided by 4,000. We got the 0.075. Okay, now we find out the probability for each event. Let's find out the probability of A or B happen. What is the probability that a particular package will be either underweight or overweight? So these two events are mutually exclusive. Why? Because you pick any bag of the vegetables. That bag or underweight or satisfactory or overweight. So you pick any bag out of the 4,000 bags. It cannot be underweight and overweight at the same time. That will not happen. So underweight or overweight are mutually exclusive event. For this kind of situation, if we find out the probability of that bag, we use the special rule of addition. So probability A or C equal to probability A plus probability C equal to 0.025 plus 0.075. We got the 0.1. So means 10% chance. We pick any bag out of the 4,000 that will either be underweight or overweight. Okay, another example about a not mutually exclusive event. Remember, for the not mutually exclusive event, we use the general rule of addition. What is the probability that a card chosen at random from a standard deck of cards will be either a king or a heart? So we know there are 4 kings in a deck of the cards. So card, we pick any card out of the 52 cards. The probability is 4 over 52. Remember, there are 4 favorable numbers because there are 4 kings, and in total there are 52 cards. So the probability of picking a card is a king is 4 over 52. Heart, you pick any card out. The probability of getting a heart is 13 over 52. Explanation is because there are 13 hearts in a deck of the 52 cards. So there are 13 favorable numbers over the total number is 52. King of the hearts. So probability A and probability B is only one. So the probability you get a card which is king and which is also heart is 1 over 52. Now let's find out the probability of you find out a card which is king or the heart. We need to use the probability of king plus the probability of heart minus when you pick up the card which is at the same time is a and is a king and also is a heart. So we call this the general rule of addition. So we use the probability of A plus probability B and minus probability of A and B happen at the same time. Another example for the general rule of addition. This diagram shows the result of the survey of 200 tourists who visited Florida during the year. Their survey revealed that 120 went to Disney World, 100 went to the Busch Gardens, and 60 visited both. So what is the probability a selected person visited either Disney World or Busch Gardens? Probability of Disney or Busch equal to probability of the people who visited Disney plus probability of the one to the Busch and minus probability of one to the both place. So you pick any person. The probability of this person visited or the Disney World or the garden place, you need use the probability of one to the Disney and plus the probability of the one to the garden, and you have to minus the probability of anyone who went to both places. So it's 0.6 plus 0.5 and minus 0.8. We call this general rule of addition for the events which are not mutually exclusive, means some events happen at the same time. Okay, rule of multiplication. Remember the rule of addition for we trying to find out the probability of event A happens or event B happens, and the rule of the multiplication for we trying to find out the probability of event A and B both happen at the same time. Both happen, not either or, but both. Okay. Special rule of the multiplication requires that two events A and B are independent. Okay, again, what are the independents? Two events A and B are independent if the occurrence of one has no effect on the probability of the occurrence of the other. This rule is written: probability A and B happens equal to probability A times probability B. Okay, let's check an example to help us understand what are the independent events and how to use the multiplication rule. A survey by American Automobile Association revealed 60% of its members made airline reservation last year. Two members are selected at random. Since the number of AAA members is very large, we can assume that R1 and R2 are independent. What is the probability both made airline reservations last year? Solution: probability the first member made an airline reservation last year is 0.6. Because you pick anyone out of that members and who booked the airline reservation. The probability of booking the airline reservations is 0.6, 60%. The probability that the second member selected made a reservation is also 0.60. So the probability of it is also 60%. Since the number of the AA members is very large, you may assume that the R1 and R2 are independent. Means you pick the first one, and you pick will not affect the probability of the second one. So probability of R1 and R2 equal to probability R1 times probability R2. The result is 0.36. What that means 36% possibilities that you pick two people who made the airline reserves last year. Conditional probability. A conditional probability is a probability of a particular event occurring given that another event has occurred. So what that means is two events are not independent. One event happens depends on the occurrence of the other. So the probability of event A given that the event B has occurred is written probability A based on the B happened. So also there are two we already learned the special rule of multiplication. The second one is the general rule of the multiplication. So the general rule of multiplication is used to find the probability of two independent events will occur. I think there is a mistake because special rule of multiplication is used to find the joint probability that the two independent events will occur, and the general rule of multiplication is used to find out the joint probability that the two dependent events will occur. It states that for two dependent events A and B, the joint probability that both events will happen is found by the multiplying the probability that event A will happen by the conditional probability of event B occurring, given that A has happened. Okay, this is the formula for the general rule of the multiplication. Probability A and B equal to probability A times probability B, given A has happened. Again, we use example help us to understand this. A golfer has 12 golf shirts in his closet. Suppose 9 of these shirts are white and others blue. He gets dressed in the dark, so he just grabs a shirt and puts it on. He plays golf 2 days in a row and does not do laundry. What is the likelihood both shirts selected are white? So the event that the first shirt selected is white, we write as W sub 1. The probability of you picking the first shirt is white is 9 over 12, because there are 9 white shirts. There are in total 12 shirts, 9 white shirts and total 12 shirts. So 9 favorable numbers over the total number 12 is the probability for you pick the one, the probability you pick any shirt which happen to be white is 9 over 12. The event that the second shirt selected is also white, but the second shirt you pick depends on the first shirt. So the first shirt is white already affected the probability of the second one is white. The conditional probability the second shirt selected is white, given that the first shirt selected is also white, is 8 over 11. Why? First, total clothes now in the closet after you already taken one white shirt out now is 11 instead of the 12. Second, you already taken a white shirt out, so means there are 8 white shirts left, not 9 anymore. So the probability for the second shirt is white now is 8 over 11, not 9 over 12. So the probability of the second shirt already affected by the first event. That means the first event, getting shirt is white, and the second event, get a second shirt is white, are dependent, not independent. So we need to use the general rule of multiplications. That is, I pick the 2 shirts, both white, the probability equal to the 9 over 12 times 8 over 11 equal to 0.55. Okay, so in this class we learned some basic rules about the probability. If you have any questions, again, please contact me by email, or we meet online on the Blue Button conference, my office hour.